Hey guys, so welcome to lesson 3-8, divide decimals by decimals. So we got two layers of decimals here. Today's date is 9/20/19. So I just wanted to show you what your spiral or your composition, notebook should look like. Two pages facing each other. I'm on pages 15 and 16. You should be somewhere near there as well. All right, I'm going to go and begin on our notes on the next page. So remember, we're already having our title in place, and we did that today in class. So let's start with a problem. We have 54 and 4/10, and we want to divide it by 1 and 7/10. So step by step, number one, we're going to rewrite the problem. Using the division house symbol. Okay, so we can't divide in that horizontal fashion the way they've got it. We're going to do it the other direction, so it actually puts it this way. 1.7 dividing into 54.4. Okay. All right. Now, here comes the thing I talked about yesterday, and it's come to reality. Something that we're not allowed to do. And I'm going to yell at you. You cannot. That means no. Just like a little toddler, right? No. You cannot multiply by decimals. It's not permitted. So we're going to have to figure out how to get that decimal on the outside. Oh, cannot multiply. Hello, let's change that word. What are we doing here? We're dividing. Let's try that again. You cannot divide by decimals. Okay? So, how are we going to get that divisor to not be a decimal? Here's the steps. You're going to multiply the divisor. And really all we need to do is get that decimal point to move to the right as many places until we have a whole number. So we're going to use that good old guy called the power of 10, but we're going to try to use the smallest one. So we don't want to put two zeros after our answer. We don't need that. So we're going to multiply the divisor by the smallest power of 10. And when I talk about power of 10, 10 to the first power is 10, 10 squared is 100, 10 cubed is 1,000. Usually I don't think we need to go beyond that in our grade. So multiply the divisor by the smallest power of 10, either 10, 100, or 1,000, depending on how many digits we need to move over. That moves the decimal point to the right, creating a whole number. Okay, so this is what we're going to end up doing. We're going to multiply the divisor by the smallest power of 10. It could be a 10, 100, or 1,000. That moves the decimal point to the right, creating a whole number. Now, I can't take a problem and take half of it and treat it one way and not treat the other part the same. So we're going to do the same thing to the dividend. We're going to multiply the dividend, but here's the key. It's not whatever it takes to get it to the end, it's whatever we did to the divisor. So we're going to multiply the dividend by the same power of 10 as the divisor. So it took me multiplying by 10 to make my divisor a whole number. I'm going to multiply my dividend by 10. Okay. So what I want you to always remember, math is fair. So fair is fair. That means we treat everything the same. Okay? All right, so let's go ahead and do that to our problem. So we have 1.7 dividing into 54.4. So I need to move one place to the right, so that's going to be the power of 10 with 1 0, so 10. I'm going to do the same thing to the dividend, and it moves the decimal point now to the end. Now that doesn't always happen, but in this particular case, it does. So my new problem, the one that I'm actually going to do division with, is 17 dividing into 544. Okay. Now we're ready to go. So third thing is we need to set up our problem by bringing our decimal point straight up. But where from? So bring the decimal point from the new dividend. Out with the old, in with the new. The new dividend straight up into the quotient. Now these should start sounding a little familiar. Should sound like the notes from yesterday. Into the quotient. Okay. And then we're just going to go ahead and start dividing. And same rules that we came up with before apply. If I have a remainder and I've run out of digits, I can annex. So we'll see that in a couple of the examples, okay? Now, let's go back to our original problem and let's finish him out. So I've got 17. This is the altered version, dividing into 54 or 544. So let's see. 17 can go into 54. Let's see, 17 times 3, I think it was. 21. I get 51. Yeah, that I can't imagine getting closer. So again, I have to be very cautious where I place things in my quotient. Since 17 can't go into 5, but it can go into 54, I'm going to go above the 4 of 54, and that's where I'm going to place my quotient guess. Now 17 times 3 is 51. When I subtract, I get a difference of 3. Bring down the next digit, and I think that's 2. Let me just double check. Yep, it's 2. So we multiply 17 by 2, we get 34, we subtract, and we have no remainder. So the answer to this problem is simply 32. Now, not all answers are going to be whole numbers. Now, I'm going to be honest with you. When I did my notes in my composition notebook, I actually got 2 examples on the same page as these notes. But the whole other page is all about examples too. So if you want to do them all together on the right side, that's up to you. So let's continue to do some more. Directions are just going to be divide. Oops, sorry. X, divide. Example. So we've got, let's see, 2 and 64 hundredths being divided by 6/10. So we're going to rewrite it. And we get 6/10 divides into 2 and 64 hundredths. This is where we run into the problem. Because my divisor has a decimal, I need to move the decimal one spot to make a whole number. That's multiplying by a 10, 1, 0. Same thing over here. Multiply by 10, 1, 0. So my problem really is 6 dividing into 26.4. This is where we're going to now bring up the decimal point into the quotient and then start dividing. Now, we discovered 2 days ago when we were just dividing with whole numbers and everything worked out nicely that dividing by a single digit is so much easier than a double digit, but life doesn't always work out to single digits. So 6 goes into 2, no, into 26, yes, 4 times. 6 times 4 is 24. Subtract. I get a difference of 2. 6 is bigger. That's good. Bring down. 6 goes into 24 4 times. So I get 24, subtract, and I get no remainder. So the answer to the first problem is 4 and 4/10. All right, let's try another one. Ooh, wow, this one's crazy. So let's see, we've got 63 10,000ths being divided by 7,000ths. So we're going to rewrite it with, the 7,000ths in front, and the dividend 63 10,000ths underneath the division symbol. Oh my gosh, do you see this? I need to move the decimal point 3 places. So that means I multiply by the power of 10 with 3 zeros. So I'm going to multiply by 1,000. I'm going to do exactly the same thing to my dividend. I'm going to multiply by 1,000. So my problem now becomes 7 dividing into 6.3, or 6 3/10. Okay, bring the decimal point straight up into the answer, and then divide. Let's see, I can't divide 7 into 6, so 0 times, but 7 goes into 63 9 times, which is 63 with a difference of 0. Wow, that terminated pretty quickly. So remember what we talked about also, if we get an answer where there's no remainder, that's called a terminating decimal. The other kind of answer you could get is a repeating decimal, and in a repeating decimal the same number just keeps coming up over and over and over again, and you'll always get the same number. So you stop and you put a repeating bar over the digit that repeats, or digits. Sometimes it's a pair of digits that repeat, or sometimes the directions will ask you to round to a specific place value column. It's either the tenths or the hundredths is what I typically see. Okay, so continuing on, we've got 9,000ths being divided by 1,800ths. So I'm going to rewrite that with the division house. So we have 1,800ths dividing into 9,000. So here's the beautiful thing about division. Doesn't matter what the numbers look like. You just do the math, right? So I'm just going to move the decimal point twice to the right. So that goes with 2 zeros, or 100. Same thing in the dividend, twice to the right. Okay, that means multiply by 100. And my actual problem is going to be 18 dividing into 0.9. So we go ahead and we bring the decimal point straight up from its new place. And let's see what happens. Well, 18 can't go into 0. Actually, 18 can't go into 9. So right now, we've run out of digits. So this is where that power of annexing comes from. So we're going to annex a 0, and we may have to do more, so it's 1 at a time to continue dividing. So now we're dividing 18 into 90. So let me think about that one. The other problems haven't had much issue because the numbers were nice. So let's see. 90. It ends in a 0. 8 times 5 is 40. That ends in a 0. So let's try that one. Bingo, bingo. That is it. So we're going to put a 5. And we get a 90. And when we subtract, we get a difference of 0. It terminates. So the answer here is 5 hundredths. And we got one more, but this one's the doozy. This one is the doozy. All right, so let's see. We've got 6 24 hundredths divided by 200. Ooh, that's crazy. So this is going to be 200 dividing into 6.24. Now, what's different about this problem is that the divisor already is a whole number, so now all I have to do is bring up the decimal point into the answer and start dividing. When I can. You'll see what I mean. 200 can't go into 6. 200 can't go into 62. But 200 can go into 624, because 2 goes into 6 3 times. I mean, that doesn't make sense. 2 times 3 equals 6. Well, no, I had it right. 2 goes into 6 3 times. So when I multiply 200 times 3, I get 600. So we have a 3. and we get a 600. So when I subtract, I get a difference of 24. When I compare, 200 is definitely bigger than 24, so far so good on my guessing. But I've run out of digits, so I need to annex a 0. How many times can 200 go into 240? Well, only once, and that is 200. I'm going to subtract. I get a difference of 40, definitely smaller than 200, so I get to annex another 0. Double annex, woo! And then 2 goes into 4 twice, so if I multiply 200 by 2, I do get 400. So 2 goes up. 400 is the product of 2 times 200, and the difference is 0, and I finally terminate. So my answer is 312 10,000ths. There you go. Have a good time with this, guys. See you tomorrow.